Now, getting into the topic API gateways and rate limiting. Imagine an e-commerce application and there's a customer sending multiple requests together. And the request could be login request, placing an order, making a payment, as well checking the inventory. Now, here the order is a service and payment is a service. And as soon as the user sends a request, they should be directly accessing the service. But that process could be smoothened much more easily by placing an gateway which actually distributes the service request to the respective services. And that is done through the API gateway. So here, API gateway acts as a main entrance of the system, performing routing request, authentication, rate limiting, monitoring, all by itself. Now, under this, there's another concept called as rate limiting, where rate limiting controls how many requests a user can send. Right? For suppose a user can send 100 requests for each minute. Then, if he suddenly sends 500 requests, then those extra requests are actually getting blocked over here. So, also let's imagine if there is no API gateway at all. Then, at that moment, client should be having a knowledge of order service URL. Suppose they are trying to place an order or they're trying to perform a payment, then they should be having a knowledge of payment service URL also. Similarly, the inventory service URL, the shipping service URL, and all. And in this case, every service must implement authentication, logging, rate limiting, security checks again and again, through which the system becomes very difficult to manage, very difficult to scale, very difficult to maintain. And that turns out the system to be very much inefficient. So for this, setting up a single gateway or one API gateway actually solves the problem. Such that if a client sends a request, then they go through the API gateway and reach out to internal services. So all traffic enters from one place, and clients only know one endpoint. So authentication and rate limiting happen once, such that system doesn't turn heavy all at a moment. Now, let's try to understand what exactly happens inside the API gateway. As soon as the requests are sent from the client side, they first go through the SSL termination, where it converts encrypted traffic into readable format, securing the communication and lowering the burden on the backend services. And then it goes through the authentication, where it checks who is the user and is the JWT token valid or not. And further, it checks is the user sending too many requests or the number of requests being sent by the user. And then goes to the transformation. That is, it modifies request or responses. Either it could be modifying from old API format to the new API format. And then finally goes to the load balancing, where load balancing actually acts like a traffic cop, standing in the traffic from all the sides and managing them efficiently and accurately. So the load balancing distributes traffic among multiple servers, right? Reducing the burden on the system. And imagining what happens without rate limiting. That is the threat of unrestricted traffic. What happens exactly if there is no rate limiter at all? Then the dangers could be faced that are abuse and bots. That is, attackers continuously send requests. And under DDoS attacks, thousands or millions of requests flood the system directly. And bad client code accidentally sends requests forever without any stoppage or without any limit and without any end. And it leads to cloud bills increasing dramatically. So there happens multiple chaos. So in order to solve this, there's an algorithm called as fixed window algorithm. And if you're trying to understand how exactly it works, here, suppose we imagine a number that is 100 requests per minute. Then counter is set up actually that resets every minute the number of requests. Suppose at 12 p.m. the counter starts and 100 requests are sent. And then immediately at 12:01 the counter resets back. And the same happens for each and every minute. So user sends 100 requests at 12:59 or 12, and 100 requests are actually received by 12:01. And the next moment, another counter starts and resets. And this happens simultaneously, leading to multiple requests being received, and yet systems allows it. So this is called as the fixed window algorithm, handling multiple requests at a time. Now, there's also similar solution called sliding window, also leaky bucket. Now, what exactly happens in the sliding window? It tracks exact timestamps of request. Instead of fixed minutes, it continuously checks the last 60 seconds, leading to no boundary issue at all. That is, no over or exceeding the number of requests. But it requires more memory. And coming to leaky bucket, you might also wonder how it works. It is similar to the bucket having a hole and the water being leaking uniformly, right? And in the same way, here in the leaky bucket, requests enter a queue and system releases them at a fixed speed. For example, 100 requests arrive together and gateway processes 10 per second. So benefit, what is achieved here is that it leads to very smooth traffic. But legitimate burst must wait. Now, also, there is another popular technique to be handling this problem. That is token bucket, which is industry standard and bit more preferred. That is, the bucket contains tokens. And for example, the bucket size is 100 tokens and refill rate is 10 tokens per second. Then each request consumes one token, such that if the token is available, then the request is processed and allowed. If not, the request is blindly rejected. And you might wonder why it wins. Because it allows short bursts while controlling long-term traffic, right? And coming to the modern systems, right now, what is existing? We don't have a single gateway. Rather, we have many gateway instances. For example, 10 gateway servers. And each server stores limits separately. For suppose, server A stores 50 requests, server B again stores 50 requests, and server C again stores 50 requests. Each thinks the user is below limit. And at the end, global limit gets violated. And this is what the actual problem is faced. So in order to solve this problem exactly, there comes the Redis into the picture, where Redis acts as a shared store. That is, it stores limit or rate limit information in Redis. And all gateway servers use the same Redis database, through which every server sees the same counter. And so Redis runs in the memory and it becomes very fast. And all servers enforce the same level. So in this way, Redis actually addresses the problem and brings out a solution. And now coming to the granular implementations in production, or also to be termed as production implementations. Here you have three tabs again: per IP limiting, per user limiting, and API key tiering. Coming to per IP limiting, the limit is based on IP address. For example, 100 requests per IP per minute. And what is benefit actually achieved here? It is that it provides simple DDoS protection, right? And the issue or risk what could be faced is that many users behind one office network may get blocked. And this is the actual risk what is faced using per IP limiting. Now, coming to per user limiting, it is a limit based on logged in user. For example, user A 100 requests per minute, and the same user B 100 requests per minute. Now, what is the benefit? It is very much accurate. That is highly accurate quotas tied directly to authenticated digital entities, right? And then moving to API key tiering. Here, different customers get different limits. For example, in the case of bronze, it is 100 per minute. And in this case of silver, 1000 per minute, or yeah, 1000 per minute. And coming to gold, it could be 10,000 per minute. And in this way, it happens actually. So here the bronze and silver and gold would be the premium tires or any tires it might be. Now, imagine you're trying to make a payment and suddenly payment service becomes slow. Then gateway continuously sends requests, right? At the end, resulting to everything that starts falling. And here the solution is gateway monitors failure rate. And if there are too many failures, circuit opens directly. Now, coming to open circuit, we might refer it to a fuse that is open in order to break the circuit, right? So in the open circuit, gateway immediately rejects request instead of waiting for timeout. So that service gets time to recover, and this is how it could be made. Now, coming to API gateway versus service mesh. You might confuse between API gateway and service mesh. But here, let's try to achieve the clarity. The API gateway handles client traffic, authentication, rate limiting, routing, and that is north-south traffic. That is from client to the server, or it could be termed as client to the system and system to the client. But coming to service mesh, it handles communication between services, which is the key difference. For example, Istio, Linkerd, etc. Here it is east to west traffic, that is between services. And the very important, they're not competitors. Most large companies use both of them. And now, coming to the other common pitfall, that is quotas are not rate limits. Or you could also try to understand as quota versus rate limit. Coming to rate limit, it is 100 requests per second, and its purpose is to protect infrastructure immediately. But coming to quota, it might be 10,000 API calls per month, and its key purpose is that for business and billing control, right? So the goal is for business logic and billing. What is the key difference? You might wonder. The difference is that the rate limit is for technical protection and quota is for business restriction. Something like a rate limit is speed limit on the road, and quota is the monthly fuel allowance. So on a whole, on an entire review, API gateway is the bouncer that validates IDs, checks the guest list, and points you to the exact Lightroom. And the rate limiter, it is the turnstile that controls entry speed, right? Controls exactly how far the crowd is physically permitted to enter. And next, the token bucket that acts as an arcade tokens. Every action consumes one token. That is, you can press buttons as fast as you want, but every single action costs exactly one token. And then coming to the circuit breaker, it acts as an electrical fuse. It disconnects unhealthy systems to protect the whole application. That is, it sacrifices the connection to save the entire house from catching fire during an overload.